Hi everybody, it's Dr. Hall continuing on with lecture 8. So we're going to start getting into the details of the menstrual cycle. In 8A we talked about oogenesis, but now we're going to start getting into the cycle itself. And so a couple of things to keep in mind just as an overview. So the average length is 28 days. So we're going to use that kind of standard 28-day cycle as a reference and a context within which to position all the different events, although normal can range from 22 to 36 days. But we're going to use 28 for simplicity purposes. It's divided into two phases. The first phase, which is for the first 2 weeks, is called the follicular phase. Then ovulation will occur, which separates the two phases, and then we enter the luteal phase, which will be the second 2 weeks. And during these phases, different things are happening in the body in terms of the ovary, in terms of both the oogenesis and maturation of the oocytes, and in terms of hormone production. And of course, that hormone production is in part going to be regulated by the hypothalamus and pituitary. And different things are also going to be happening in the uterus, particularly that endometrial lining. So we're going to kind of talk about all of those different components as we move through the phases. Okay, so the first phase of the menstrual cycle is termed the follicular phase. It's called that because during this phase, the follicles are developing and maturing. So this is just a slice out of that graphic that I showed you at the beginning of the last lecture. And what you can see is this is what's happening in the ovaries right here. And we can see follicular phase. And we can see that these follicles are developing and becoming mature. So that is kind of the overarching event of the follicular phase, hence the name. Now we're going to get a little bit more into detail. So this is what that process of follicular maturation means. And so you'll recall that the oocyte is inside a follicle. So we start here with a primordial follicle, right? So kind of almost prehistoric. And then and it's surrounding the oocyte. So here in the middle with this orange nucleus, that's the oocyte. And then that follicle is going to start to grow and enlarge and get more and more cells around it. And there's going to be two different types of cells we're going to find. These blue ones are the granulosa cells, so I'm going to give that a G. They surround the oocyte directly. Then these pink ones that you can see here that are around the outermost area are the theca cells. And so we're going to talk about those two different cell types and what they do in this part of the lecture. Eventually, this follicle, right, this ball of cells that's surrounding the oocyte, will get bigger and bigger and become filled with fluid. So that's what we're seeing here, is it becomes filled with fluid and it becomes mature and ready to ovulate, ready to kind of spit the egg, the oocyte, out of the ovary. These are some other images. So this top one, again, reminding you this is happening in the cortex of the ovary, the outer portion of the ovary. And then they've included some actual microscopic pictures here looking at actual developing follicles with the oocytes inside of them. And so I just want to point out to you here that when it becomes fully mature, we call a follicle a Graafian follicle. And here is the oocyte right here. So here it is in this diagram. Here's the oocyte here. So we're going to look a little bit more in detail now at these follicles and what's going on. So during the follicular phase, at the beginning, estrogen levels are low. So remembering our negative feedback then, the hypothalamus looks around, says, estrogen is too low. I must do something. So it's going to secrete GnRH. And that GnRH is going to travel right next door in a paracrine fashion to the pituitary gland, which then says, yes, boss, and starts making its two hormones, LH and FSH. Those are going to travel through the bloodstream in an endocrine fashion to reach the ovaries, which are far away, so they have to take the bloodstream to get there. And what's going to happen is that LH is going to tell the theca cells, those cells around the outside of the follicles, to make hormones. And FSH is going to tell the granulosa cells, those ones that are right next to the oocyte, to help mature the oocyte. So if we remember way back to lecture 4 and how we do hormonal regulation, this should all sound kind of familiar. But what I also want to point out to you are the parallels between the male and female systems, right? So LH is going to be the hormone produced by the pituitary gland that tells the gonads to make more hormones. So in the case of the testes, then here on the left in blue, that means LH is going to stimulate the Leydig cells because it's the Leydig cells that make testosterone. And you might remember that the Leydig cells don't sit inside the seminiferous tubules, they're around the outside. So that's kind of an interesting parallel because in the ovaries, LH is going to signal the theca cells to make hormones. And of course, the theca cells are outside of the follicles, right? These outsider cells are the ones that are going to make the hormones for us. FSH, of course, follicle stimulating hormone. That's what it stands for. Now it makes sense. Follicles, it's all about follicles. But there are no follicles in the testes, so I don't know. But it's still the same hormone. So in the testes, you might remember that FSH tells the Sertoli cells, those nurse cells that protect and nourish the sperm as they form, to get to work and encourage the sperm to do their thing and to mature and to make spermatogenesis happen. And in the ovaries, FSH is telling the granulosa cells to do the same thing for the oocyte. So FSH is going to cause the follicle to mature, and as the follicle matures and does its job, that's going to encourage the oocyte to mature, go through meiosis, and get ready. So let's look a little bit more closely at some of these follicles. So when they start off as kind of baby primordial follicles, what we can see here is it's just the oocyte for the most part. And then there are just these really flat cells surrounding it. So that's the very beginning. And then as they develop and mature under the influence of FSH, we're going to get these nice thick cells here. That doesn't show up very well. Let me try this. These cells here are the granulosa cells, right? Those are the ones responding to FSH. And then out here, right, are the theca cells outside the follicles here. So the granulosa cells are inside the follicle directly surrounding the oocyte. Theca responding to FSH. Theca cells are outside the follicle responding to LH and making hormones. So we can see the oocyte in the middle here, and we can see its nucleus with its chromosomes inside, which is like so cool. And then we can also see there's this thick kind of like shell. It's called the zona pellucida, right? It's this whole layer around the egg. And it's this thick protein-rich goo that surrounds and protects the oocyte. In fact, it reminds me of mochi ice cream. So if you've ever had mochi ice cream, if you haven't, you owe it to yourself. But it's this kind of gooey, thick outer covering that surrounds the oocyte. So it reminds me of that outer covering around your mochi ice cream balls. Maybe I should bring some to class. Yes? Okay. And that's going to be important later on when we talk about fertilization, when the sperm actually burrows into the egg. So zona pellucida. Okay, so here's another image where again you can see we've got multiple layers of these granulosa cells that they're calling membrana granulosa here, but they're just granulosa cells. We have that zona pellucida around the oocyte. And then we have those theca cells that are sitting outside the follicle and producing hormones. As the follicle continues to enlarge, we get more and more granulosa cells. And so we see this image on the left is a follicle that's continuing to mature and grow. The oocyte within it is continuing to mature and grow and get ready. And then we get to the point where the follicle is almost entirely filled on the inside with this space filled with fluid. And as that happens, some of the granulosa cells stay in a ring right here all around, forming the wall of the follicle. We still have our theca cells that are outside the follicle. You can see them there to the left. Then there are also some granulosa cells who decide to stay around the oocyte. And so at this point in time, we're going to give them a new name. It's going to be the corona radiata. So remember, corona means crown, so they're kind of forming a crown or a halo that's radiating around the oocyte. So we have some granulosa cells that are forming kind of the wall or the outer boundary of the follicle as it accumulates fluid within it. And then we have some granulosa cells that continue to directly surround the oocyte, and that's also going to become important later on. So the follicle now is mature, and we call this a Graafian follicle, and it becomes filled with fluid, and it's kind of almost like a pimple that's ready to pop. So just a reminder, right? The LH is telling those theca cells to make hormones. So before we get to the what happens with ovulation, which will happen next, let's just talk a little bit about how the theca cells are making hormones, because that has relevance to some of the disorders we'll talk about next time. So it's super strange. So the theca cells sitting outside the follicle respond to LH and use cholesterol molecules as their ingredients. So we have cholesterol over here, and moves into the cell. And the theca cell is going to turn that into a hormone called androstenedione. We call that an androgen. Andro means male, gen means creating. So these are masculinizing hormones. So it's going to make androstenedione, which then moves into the granulosa cell. So it's not just the theca cell that makes hormones. The granulosa cells are also really important too. And the first thing the granulosa cell is going to do is turn it into testosterone, right? Which you know is an androgen, a masculinizing hormone. And then it's going to convert that via an enzyme called aromatase to estradiol, which is estrogen. And it's that estradiol or estrogen that is going to cause the oocyte to mature. So I just want to point out, it's really crazy that in ovaries, the way you make estrogen is by making androgens, including testosterone, first, and then converting it into estrogen. That's the chemical pathway. So if you own ovaries and they're not suppressed by a certain type of birth control, perhaps, if you own functioning ovaries, they are right at this moment making testosterone. But if things are proceeding according to the typical plan, most of that testosterone, if not all of it, is then being converted into estrogen or estradiol, which is kind of cool. Okay, so back to our mature follicle. So we have the oocyte in the middle, surrounded by the corona radiata, and then this fluid-filled middle, which is called an antrum, and the granulosa cells forming a ring in the boundary of the follicle around the outside. Theca cells are outside the follicle itself. So at the end of the follicular phase, this is our whole goal, is to get one of these. So generally, each follicular phase, there will be about 1 to 2 dozen contenders who, oocytes and follicles that try to mature, but only one of them will be allowed to make it to the final stage. So what's happening with the uterus during this follicular phase, right? So obviously follicular phase is named for the follicles. They're going to mature and develop. So the oocyte matures and develops and gets ready to be ovulated. The uterus, interestingly, the endometrium at the beginning of the follicular phase is saying goodbye to the remnants from the previous cycle. So the endometrium is actually shedding as a menstrual period for the first several days, if not a week, of the follicular phase. And then in like the second week, it starts to build up a new lining. So you might wonder, like, where did that lining come from? Well, we'll get to that because it came from the previous cycle. All right, so it seems strange that at the beginning of a menstrual cycle is when you are having the menstrual period, right? That's when you're bleeding. It's weird, I know. Okay, so in summary, right, follicular phase is the first 2 weeks of a standard 28-day cycle. The hypothalamus is making GnRH, so the pituitary makes LH and FSH. That causes the FSH causes the granulosa cells to mature and has the follicles mature and causes the oocytes to mature. And LH is stimulating the theca cells to make hormones, particularly estrogen. So you can see in the image on the right-hand side that estrogen is that kind of orangish curve. Let's see, this one here, right? This orange one. So estrogen levels get quite high during the follicular phase. And then we can see down on the bottom, that's our little schema graphic of the uterus. Beginning of the follicular phase, we're having a menstrual period, and then we start to build up again due to the influence of those high estrogen levels. So that's it for follicular phase.